So next I'm going to show you how to change the password. So this is the first card in this video series we are seeing where the card can have a password. I'm going to explain you how to use the password or how to protect the password, how to protect various pages of this tag by a password. So very first thing you are going to do is give a password to the tag. The password is stored in page number 18, and there's something that's related to password which is stored in page number 19, and this is called as the password acknowledge. So there is no separate command to change the password or to change the PAK. I'm going to keep this PAK just for a while, keep it aside for a while. So let us see how the password is set and how we can use it. So password is changed by a simple write operation. So I've got a section here that's called password section. Okay, I'm going to change the password. Say for example 10,000 is my password. So I'm converting this number 10,000 into hexadecimal with the lower byte on the left side and the higher byte on the right. So I'm going to write it. So this is just a ordinary page write operation, and immediately I'm showing you the content of this password page. However, keep in mind, if you try to read, say for example if I activate and try to read the tag, you can never ever see the value of the password. So the password is protected from a read operation. So you have to remember the password. So the next thing is about what is the purpose of this password. So this password can be used to protect this entire tag, or you can protect starting from a certain page number. So all these settings is done by means of the configuration page, which is available as in two pages, at page number 16 and page number 17. This is called configuration 0 on and configuration 1. So before we go there, so let us also see what is this pack. So just like if you look at the documentation, the memory map of this document, you can see that somewhere here the pack is, if you see this is the best document to follow. The pack is a 2-byte value, which is also called a password acknowledge or a positive acknowledge, and this is any number you can keep here, and this number is read only after a successful password authentication. Say for example, so you can visualize like this. Assume that we have got a box with the value of the pack inside the box, and when you send the password and if the password is right, this is called as password authentication. So when the password is right, whatever is the value inside this box, that is the value of the pack, will be returned as a output. This is the response. So this is some kind of a secure chamber where the value that is inside this chamber is returned or can be read only after successful password authentication. So before we use this, we must have some meaningful value there. So I'm going to store this again. Writing here is just done by ordinary write operation. So I'm going to show here now. So assume that I'm going to write, you can write anything, it depends on, before that I need to change. Let me write 100. So I'm going to write 100 to the page 19. If you look at the commands, this is just a ordinary page write command, and which will return you the acknowledge, the positive acknowledge. And what we have got now is we have written the password and we have written the value of the pack. Now if you close and read this entire tag again, you can see that the value of the password and the PAK cannot be read. They are all zeros. So that is how just keep in mind, for a new tag or when you are customizing the tag, you must always give a password and depending on application you can either have the value for PAK or you can ignore it. So next I'm going to show you how do we authenticate. So how do you authenticate with the password? So there is a separate command, so that is called as, if you scroll down, or you can just go to the index page and look for the password auth, and here the command is pretty straightforward. You send the password, you send this command code IB followed by 4-bit password. If the password is correct, you will get back 2 bytes of the value of the PAK. The password is wrong, you will get a negative acknowledgement. So you can see the values for the negative acknowledgement here, and you can see that. So if you remember, in one of the command we got the 4 as a value of the acknowledge. There is NAK for count overflow. Yeah, I remember that. I think when we try to write a number which exceeds the 24 bits, we got the result as 4, which again documentation says it is a negative acknowledgement for count overflow. So likewise, this is something interesting here as well. So we have been seeing this code A, it's called positive acknowledgement. Any other value you get is a negative acknowledgement. Okay, so let's go back to the password command. So this is how the command works. You call this command with the password. Now the card, the microchip inside the tag verifies the password. If the password is right, it will return back the acknowledge. So let us give a try. So we know that the password is 1000. So before you click on this is the button to authenticate. So as you can see here, I've also got some nice message here that says right now this tag is not authenticated, and we're going to authenticate, but before that I know the password is 10,000, and I'm going to say authenticate. So I got a positive message. Let us see what's happened in the background here. Now this is the command I'm passing. The password command is 10 followed by, this is the hex equivalent of 10,000, and we got a positive acknowledgement that we got this value 6400, which is nothing but, as you can see here, I'm populating the value of the PAK here, and also I'm showing the decimal equivalent of that. So now the tag is in a different state altogether. If you go back to this state diagram, and we have never visited this state, and we have been always we have been right from the halt, we have been in the active state, and now we have done the password authentication. Now the tag is in the authenticated state. So it just the tag remembers it is in authenticated state. So now you can just do read and write operation like before. Next we are going to understand the configuration pages, which is present in page number 16 and 17, and in the 16 it's called as a configuration 0. There is only 2 pieces of information here. One is at byte 0 called MOD, that's called modulation, and at the byte 3 called authentication. And in page number 17 you got again I got only 2 pieces of information. One is called access, another is VCT ID. Okay, so again if you go scroll down, the mod byte, the value that's present in here is also explained. So this is the mod byte. So this byte, there's something called strong modulation enabled. So if you look at this table here, it says it's a 1-bit value which is either 0 or 1, and the default value is probably it's 0, I suppose. So what it means, I never tried this myself. Just I think something to do with probably the antenna strength or signal strength. So you can play with this. So this bit controls whether it's a strong modulation, disabled or enabled. 0 means disabled, 1 is enabled. So after that, let's go and make this an explanation. Again, you can go through this, and let us see. Let us try to use this bit. So assume that I want to protect my this tag. Okay, let us write something here. Probably I'm going to write from page number 6 onwards. I can write some text. This is, say for example, Mifare Ultralight EV1 tag. So I'm going to transfer this to 6. I'm going to write this from 6 to write it to page number, say, 13. Right. Okay, so now write is successful. So assume that, see, the way the password protection work is, it's something, it's a little bit different than what you would expect. So I can configure this tag to enable the password protection starting from a page here. Say for example, I can configure that anything from page number 4 onwards up to the end of this, up to page 19, it is password protected. Or you can say that everything from page number 0 is password protected. Or you can say that the last 4 pages, say for example page number 15 onwards, I want to protect the pages with the password. So here what we have to do is we have to first specify the starting page number. So that is what is done by this field called auth0, which is in configuration page 0. So auth0 tells us from which page onwards we have to protect. So I'm going to say for example I want everything from page number 6 onwards need protecting. Okay, so I'm going to write. So now I've written, said that it's you can still make this as enabled, the strong modulation. So again, changing the value of the configuration 0 is just a simple write command here. So just going to, yeah, so what we have done is, so this value here which is now it's 6, it says from page number 6 onwards it is password protected. And again you can control the type of the protection, whether you want to control the write only. So if we say it's controlled by in the configuration page 1, so I think it is, I'm going to show you where exactly I got these values. So this property here controls whether you want a write protection or both read and write. So let us keep it very simple. So I want, as you can see, the default value is write. So the grid here shows already that from page number 6 the PROT column says W, so it's write protected. So all these whenever you change the configuration, they come into effect only after you reactivate the card. So reactivate is physically taking out the card and putting it back into the field. So we have a situation now where the page number 6 onwards is write protected. But let us try to, I'm going to go to page number 6 and say for example I would like to change the value of, I'm trying to change the value of page number 6 which is write protected. So let us try to do what happens, right? So the write failed. So let's see what exactly has happened here. So we got this is the 00 is what we received. It's a negative acknowledgement. So you can have a look at that what is 00. So look at here, 00 is also a negative acknowledgement and some kind of invalid argument. So it is an error basically. So it is an error now, I cannot write. So keep in mind, whenever the tag raises an error, it will go back to the idle or a halt state. If you try to read, you'll always get this error. The only way to come out of that is either reactivate and read. So read it. Now how do we change this page number 6 onwards? So in order to do that, I have to first authenticate. I have to bring the tag to the authenticated state. If you remember the state diagram, so I know the password is 10,000 and authenticate. So authenticate, you got this PAK back. So now let us go and try to change the value of page number 6. So this time write A B C D. Right, so now write is successful. Keep in mind everything from page number 6 onwards up to the end, up to the page number 19, there's a small bug here. See here, this is my programming bug. Keep in mind the counters are not controlled by the password, so you can always change the value of the counter irrespective of the password. So let us give a try. So I'm going to reactivate, activate again, read the tag. I'm going to just, I know that everything from 6 onwards to page number 19 is password protected. This is my software error, as I mentioned. Probably I will try to remove this thing. So if I'm going to increment the counter by 10, right, it's successful. So you can always modify the counter. So the counters are not controlled by the password. So let us try to even keep in mind anything. Okay, assume that I want to change the configuration. So configuration page is again is controlled by the password, is write protected, and you need a password authentication. So let us try to play with this configuration for some more time. I'm going to authenticate, because without authentication I cannot change anything beyond the page number 6 onwards. Authenticate. Yeah, now let us go with the read and write both. Okay, so this time I'm going to say, for example, from assume that we have a done a software and integrated with this tag. Everything from page number 4 onwards is both read and write protected. I want to do that. So first thing I do is I'm going to change this auth 0 value to 4, right? Then I'm going to change this PROT to read and write, right? And as the documentation says, so this will get effective only when you reactivate or repower the tag. So let's go here, activate, and this when I hit this read tag, I'm going to read all pages from 0 to 19. Let's try to do that. Look at that, it failed. So you are able to read from page 0, 1, 2, 3. However, after that it's failed. You got, this is just an error message. So we know the reason why this is, because from page number 4 onwards it is now protected. So first thing, the way you come out of this is, so I'm going to reactivate, then I'm going to activate. Now this is something I have done. As soon as I activate, I automatically add the password and password acknowledge pages here. Now if I hit a read, you can read all. Now the one more way to do that is, if you know these tags are protected, the first thing you do, before you hit this read tag, I can authenticate. Or before that, I'd like to say something. So you can always run these commands without any authentication. Okay, so let's go to the password. I'm going to authenticate. Now before we start reading the page 0, I'm trying to authenticate. So now, sorry, it's authenticated, that's it. Now read the tag. Now you're able to read and write. So I can also do something else here. Assume that I want to, I don't know now who does this thing, but let us try to protect from page number 0 itself. So I'm going to write. I can write here, no problem, because I'm in the authenticated state. So I'm going to change the starting page for the password protection to 0 itself, right? Now it's everything is protected. Even the OTP cannot be changed and lock can't be changed. So let us try activate and read. Look at that, even we are not able to read the very first page. So with this fault, the page, the card has gone to the halt state. So I'm reactivating. Now I'm going to authenticate. Now let's give a read command. Oh, okay, so looks like there is something wrong here. Probably now, I don't know whether it's something to do with the tag, or let's try to do this again. So activate. Now I'm going to authenticate. So authenticate. Now I'm going to hit read. So it's working. So I don't know why. It could be a small bug glitch in the program, or sometimes these cards somehow they lose, because it could be because I place this tag right on the surface of this board. Something like this is possible as well. Okay, so this is how the password authentication works, and we've got a couple of things to cover. So we still need to understand what is authlim and VCD and the change block, plus there's something else here which is under the lock, the VCSL command. So what I'm going to do next is remove this password protection of the entire tag. So to do that, we just have to set the value of auth0 to a number more than the last page number. So I can set this to default 255, or you can just set it to 20. So I know that this tag has got to 19 pages. This 20 will do for me. So right. So now none of the page is password protected. So what you have in the PROT value doesn't matter at this time. So let us see if this is working. So you have to take away the tag and put it back into the field, activate and read. Okay, so now the tag is back to any protection, without any protection. Next I'm going to show you about the authlim. So this is a field in the configuration 1 page. So if you look into the documentation, so in the documentation, the configuration page 1 has got two important bytes, the access bytes and VCT ID bytes. If you look into the access bytes, so all this information is bit encoded. So here in the access byte, you will be accessing the bits here. The last 3 bit is the authlim. It's called authlim. So what is authlim is very well explained here underneath. And the first bit is PROT, and this is the CLAK and so on. So if you look at this authlim, so here it says limitation of negative password. So this is a very important feature if we have to protect our password protected tag from somebody trying to use some kind of a brute force method to break it. So the value here, this is a 3-bit value, so you can go up to 0 to 7. So when the value is 0, so the card doesn't track the negative or wrong password. If it is more than 0, then the tag will track the negative password. If the user tries to authenticate or use the wrong password this many number of times, the card automatically gets locked. So you cannot do any more operation that is defined by the protected thing here. For example, if it is a write protected card, and you assume that the authlim is set to 3, so what it means is after 3 unsuccessful, it has to be consecutive. So as soon as the wrong password attempt should be in a continuous pattern. So after the third attempt, this tag get locked and you cannot do the write operation. Even assume that on the fourth attempt, even though you know the password, you cannot do the write operation. I'm going to show this, and this will be the probably the last the command, because once you did that, you are literally destroying the tag. So there is one more feature which is which I'm not very sure, which is called as the virtual tag ID. The documentation explains about this, but I don't want to comment on that because I've never used it. I'm not very clear when this concept is used. But what it is there is a separate command called a VCSL command. So if you send that command, let me see what happens when you send that command. So when you send that command, you get the value 05. So the command structure is it's a bit different. What documentation says is we have to send the 15 or 16 bytes of installation identifier, followed by the 4 bytes of PCD. So you literally sending 20 bytes, and what you get is a value that is in one of the configuration field. In the configuration field here, say take for example, I'm going to set this to 50. So I could, yeah, so 50 is saved here. So if you go to the read here again, so you get this 15 hexadecimal. So what you enter here is a decimal, so you got the value. So probably this is depends on probably we can use this feature to identify our installation or the software. Say for example, assume that I have a system. This is the reader writer, and this reader writer will identify all the tags which has got the virtual card identifier as say number 12. So we can have a program running in the PCD. So after sending the VCSL command, you get this number 12. So our software can decide whether to accept any card with that has got 12 or not accept it. So this is some kind of a it's a feature available in the tag. So it all depends on how you want to use this feature. So I don't know anything more about this thing at this moment of time. So there is one more feature called the configuration locking, this bit. So right now the configuration lock applies only to the page number 16 and 17. So if you see at this point of time, anybody can go and change the configuration. So assume that I have had authlim of 3. Somebody can go and change authlim as 0. So it's all possible because this is open. So assume that what I want is I want a tag to be completely free of any password authentication, but I do not want anybody to change the configuration. So in order to do that, you have to apply you have to set this bit locked, and then once you write it. So let's try to do that. Probably that will be the last command with this tag. So I'm going to lock the configuration. So before I do that, I'm going to say, so anything from page number 4 onwards, it's password protected, and also I want the negative authlim to be 3. So let us try to only write. Okay, the write is only the write operation is password protected, so you can still read the entire tag. And I'm going to assume that I'm going to set the authlim to 2. I'm going to write it. So I'm going to have the VCD as say for example 12 and write it. So we have finished with the configuration. Probably, you know what, I don't want strong modulation, I can write it. So you can keep writing, you can. So I have done with my configuration of this tag. So I have finalized, you know, what should be the configuration. I'm going to lock it, say locked. I'm going to write this back again. Okay, now let us try to reactivate this tag. So I can read, I got no problem reading. So you know that, you know, the config I'm showing here as locked as yes, because this is locked. And if you try to, probably, you know, this is my software, you know, trying not to write the log, let you write here. So let us try to write here. So write to page number 4. So let's go here and type, say ABCD. Oh, so obviously, you know what, so I tried to write without authentication because page number 4 onwards is password protected. So because, you know, now because there's a failure in the command, we have to reactivate. And remember, our password is still 10,000. Authenticate. Okay, now let us try to write. So I'm able to write, that's fine. Now what I'm going to do is I'm going to reactivate the tag. There's something wrong here. Reactivate. Yeah. So when these things happens, and I just try to replace the tag and reactivate again. So I'm going to use wrong password, say 1000, activate, activation failed. So you cannot, you know, keep on trying the password. That's a good feature to have. So you cannot have somebody, you know, a loop through numbers and start activating it. So if you try to read, you'll get an error. So you have to reactivate this again. So we are already done with the one wrong password, and I'm going to try. You don't have to click on a read, probably. Now I can just try here. I'm going to try with one more wrong password attempt. Authenticate, it failed. So reactivate. So let's try to read. I can read it. So we have got 2 negative activation, and not very sure whether it's 2 and above or 2. Let us try to activate with the actual password. Authenticate. Now authenticate is successful. So with this, you know, I should be able to write. Right. So the write is successful. So it looks like, you know, it's probably this number probably says anything more than 2, I suppose. Yeah, let's give it a try. So I'm going to, this time, you know, I'm going to use wrong password 3 times. So 1, authenticate is failed, reactivate. Number 2, authenticate failed, reactivate. Now I'm going to try the 3rd time. Authenticate, it's failed. So let us try to read, and I'm going to use the correct password this time. 10,000. So the authentication is failed. I'm not very sure. So it should be, I don't know whether the whole thing, even everything fails now. Let's try. So it looks like probably you cannot authenticate at all. So that's what we just saw. And that's all. You can't authenticate. Then I still have to go back to the document and say I'm happy with what it is now. Okay, because it looks like it's been locked. So if you look at my video on which is done 2 years ago, my original videos, probably I have mentioned something about this there as well. So I think that's all about this Ultralight EV1 tag.